Okay, ladies and gentlemen, we're starting a new chapter today. This is chapter 6, Systems of Linear Equations and Inequalities. And today we're just going to learn the most basic way to solve a system of linear equations, which is to graph them. So go ahead and fill out your goal sheets and we'll get started. Okay, so let's go ahead and activate some prior knowledge. Using what we know about lines, can I write an equation for the lines on this graph? Well, you should say yes, absolutely. And most of you are going to go directly to y equals mx plus b. That's the easiest way to write the equation of a graph. So the first thing we need to do is look at the y-intercept. We're going to look at this line here first. And we've got a y-intercept of 3. So we've got y equals something x plus 3. And if we find another point, say that one right there, so it looks like we're going down 3 over 2. And let's see if I can squeeze an x in there. Beautiful. So we wrote the equation. Excellent. How about this one here? You'd give it a try. So we're crossing at 4. And I need my x, and my slope is positive this time, and it looks like it's rising 1, running 1. How about this one down here? It's got a y-intercept of negative 1, and it looks like we're rising 1, running 1. Okay, so what we're talking about today is things called a system of equations. And that's when you're dealing with more than one equation with another equation. So what we're trying to do today is we're trying to solve a system of equations. And when we say solve, we mean find the place where they intersect. So notice that this place here that they intersect is not exactly at an intersection that we can label with a coordinate pair, nor is this one. But we're going to look at ways to solve those. All right, so the first thing I'd like you to do is I gave you a organization type worksheet that has the different ways that we can solve it, or methods, and the idea about the different types of solutions. We're just going to slowly start filling this out. So for today, I'd like you to write in for graphing, this method is best to use when you have both equations are in slope intercept form. And remember, slope intercept form is y equals mx plus b. It will work when it's not like that, but it's not as much fun. And then today we're just focusing on what one solution looks like. And the solution is the point of intersection of the lines. Okay? And so if I were to graph that real quick here, let's say I have two lines, this pretty one and this pretty one. The intersection is the solution. Oop, that's ugly. Okay. So moving on, let's do some practice. Let's give this a try. So, like I said, we're talking about one solution here. That means there's one place where the two lines intersect. So let's graph these two equations. The first equation, we have y equals 2x plus 3. So again, we're going to start at the y-intercept, which is 3. And our slope is 2 over 1. I'm just going to make that nice and long of a line here so I can see exactly where that line is going through. I can connect it with a straight line. And now I'm going to graph the second one, which starts also at the same y-intercept of 3, and it's going down, it's rising 1, running 2. And I can connect those. So the place where these two lines are intersecting is at the y-intercept. They have the same one. Okay? So my solution is 0, 3. The graph is my work. The solution, ordered pair, is my final answer. Let's try another one. Okay, graph number 1 starts at the y-intercept of -3. And then it's got a rise over run of 1. And graph number 2 is starting at 1. And it's rising and running a -1. So we can see exactly where they're going to overlap. Now, obviously, you guys, I'm doing a bit of a sloppy job here with my intersections, and I apologize, but you guys are going to be perfectly accurate here. So we can see these two lines have intersected at the ordered pair to -1. You have to write the ordered pair, otherwise you have not completed your answer. All right, now, as you guessed, we've got a word problem. Of course we have a word problem. Okay, so let's see how this applies to the real world. We got Alex and Amber are both saving money for a summer vacation. Alex already has saved $100 and plans to save $25 per week until the trip. Amber has $75 and plans to save $30 per week. In how many weeks will Alex and Amber have the same amount of money? So we're going to write two equations. One equation will be Alex and one equation will be Amber. We're going to let x equal weeks and y equal money. Okay, so for Alex, we've got y equals, he's saving $25 per week. Sounds a lot like slope. And he already has saved 100. That's his starting point. He started with 100 and is going to save $25 per week. With Amber, she is saving $30 per week. That's her slope. And she started with 75. So on my x-axis down here, I've got weeks. And I'm just going to go by ones. And on my y-axis up here, I've got money. And I think I'll do a little squiggle. And I think I'm going to start at 75. And let's go up by, let's see here. Well, I'm looking at my slopes, and I've got one slope of 25, and I've got one slope of 30. I wonder what would happen if I go up by 5s. 75, 80, 85, 90. I wonder if I'll be able to fit it all in there and be able to see where those two lines cross. We'll see. Probably not, but we can always extend it and make it bigger. Okay, so let's go ahead and start some graphing then. Let's graph Alex first. He starts with $100 and he raises $25 per week. So $125 per week. So that's Alex's line. And Amber's line starts at 75 and she's saving $30 per week. So that's Amber's line. So yeah, we've got a really bad graph here. We need to make it bigger. Okay? But what I would recommend is that you continue the y-axis here in this direction and keep going. Keep rising 30, running 1. And see where they intersect. All right, I erased my graph and started over, and you can see now by the blue dots being Alex and the purple dots being Amber that at week 4, both of them have reached $200. Okay, so in how many weeks will Alex and Amber have the same amount of money? 4 weeks. Excellent. Okay, so what I'd like you guys to do for homework tonight is page 338, numbers 7 through 9. It's just 3 problems, so I'm expecting you to do a really neat job. Take those 3 problems, show me all your work, find your solutions, and then we'll take a look at those tomorrow, and we'll look into no solutions and infinite solutions tomorrow. Good luck. Have a good night.